Here, I'm going to set up a classification dataset for classifying between images of dogs and hot dogs. So I've already got a bunch of images on my machine. And I put them in two different folders to represent the different classes, dog and hot dog. In fact, I'm going to put them inside another folder called classes. And I'm going to start turning this into a PyTorch dataset. So what we want to end up with is something which we can index to get a particular example, where the example is a pair of the image features and the classification label. So it's going to look something like that. So the standard approach to doing that in PyTorch is to create a class which can be indexed and will get you the items as you expect them. And these PyTorch datasets should always inherit from Torch's dataset class. And that's going to make sure that everything's set up correctly so that your dataset can be used with PyTorch models. So these dataset classes need a few methods defined. They need an initializer. They need a getItem, which defines how to index the dataset. And they need a len method so that PyTorch can figure out how long they are and so they can easily be used with PyTorch data loader. And the way I'm going to use all this is by initializing an instance of that class, which is then going to allow me to get the item out like this. So now I've basically just got to fill in these three methods. So in my getItem, I know that I'm going to basically need to load in an image, turn it into a PyTorch tensor, and get an index for the label. Remember, this getItem method defines a behavior for when I index this instance of a dataset with square brackets like that, and whatever index is passed into the square brackets is going to be provided as the index here. So what I want to do in this method is use that index to get out the example in the dataset at that position. But right now, I don't have any of the data loaded in, so I should probably do that in my initializer so that I've got it all ready for whenever it's indexed. And again, just to make it really clear, these datasets you can implement however you want, and they're probably going to vary depending on exactly what problem you're trying to solve, exactly how your dataset is laid out, exactly what it is and how it's stored. So in my case, I want to look in this classes folder, find the names of each of the classes, and then get all the file paths to those images, and then load those images in. So to do that, I'm going to import OS, which is going to allow me to list what's inside the classes directory. I'll just specify the folder that I want to list. So that's going to be a list of the different classes. And at this point, I may as well use that list to map between the list and the index, which is going to be the discrete label. So I'm going to create a dictionary which maps between the name of a class and the label. And I can use a dictionary comprehension for that. So at this point, I should definitely have already run my code to make sure that things are working as I expected. So let me do that. I'm going to print this classes to index, just to demonstrate what it is and check that it works. Great, so yeah, I get an error down here, but that's because I haven't implemented that part yet and I haven't defined that variable. But you can see above, I've printed the class to index map. So what that is maps the class name to the index. And I'm going to use that to set the label for every different example in my dataset based on the name of the folder which is stored in. And what would probably be useful would be able to go the other way as well. So I'll create a reverse mapping of that same dictionary, which is really easy to do. You just use another dictionary comprehension which goes the other way. So that's going to return me a list of tuples, which include the key and the value for each different key value pair in that dictionary. And then I'm just going to swap the order so I can map in the opposite direction. So now what I need to do is get all the examples. So I'll just list whatever's in those folders. To get the path to that folder, I'll just join the parent folder and their name. And that'll get me the example image file paths. I'm just gonna print that, check that everything works. And there you have it. So these are all of the images inside each of those folders. But I'm going to want to include the full relative path to each of those folders rather than just the file name itself. So for every example there, I'll map it into a string which contains the classes folder and the class name folder using a list comprehension. So now I've got the relative file path for every example. Now I want to combine these lists together. So that would have been an easy mistake to make, because I don't want to add a list to this list, otherwise I'll just have a list of two things in, two lists. Instead I want to extend it. And so that should add not the whole list, but every item in the list to my list of all the examples. So I've got all of the image file paths, which are easily going to allow me to open that file and get the features, but I don't have a label yet in this list. I know I've called this list all example image file paths, but I might just call it all examples actually. And the reason I'm going to do that is because when I add an item to this list, I'm actually going to add a tuple of the file path and the label. So I'm getting closer to what I want here. So I'll have the file path and the label, and then later I'll just take that file path and turn it into the image features. So what I'm going to do is, instead of just having a list of the image file paths, again, I'm going to map those into something else. So for each image file path in the example image file path that I've got, I'm going to return a tuple of the image file path and the class name. So let's see what my examples look like so far. It looks like this. So every example currently looks like that. The next thing that would be pretty easy to do is to change this label into an index. And I can do that using this class to index dictionary, which I created earlier. I'll just index it with the class name. And then that should get me the index. Great. So now I can see that for each example, I've got file path to the image and the index of the class. So all the dogs have index 0, all the hot dogs have index 1. And then I want to use this list in my get item, which can define the behavior for when I index an instance of this class. So I want these examples to be available in that method, so I'm going to define them as an attribute called self.examples. And to make things easier, I probably should have just done that from the start. So now, when someone indexes a dataset, what needs to happen? They need to get the image and the label. In fact, those two things can happen at once now. And all I need to do for that is index my self.examples with the index, which is passed into the square brackets when someone indexed the instance of the dataset. So that's going to give me this tuple of path name index, and so I can just unpack that. And that label is already in the form which I want, it's an integer. So I've already done this in here. So all I've got to do now is turn the image into a torch tensor. So the first thing I need to do is load in the image. And I use pill to do that. Let's just check that's working. Yeah, I've got an image of a dog over there. So now I need to turn this pill image into a PyTorch tensor. Well, I know that I can find a transform to do that in torchvision.transforms. And instead of initializing this transform every time I get an item, I'll put it in the initializer. I can tell that's a class, so I need to initialize it, and then this thing is going to be callable. So I can call it on my image, and that's going to return me the image as a tensor. So now, for the first time, the image comes out in tensor format. That's exactly the format that PyTorch model is expected in. So what I'm going to call that is actually features. Those are the features which are going to be returned from each example. So at this point, I'm pretty much there. So now I can use this class as intended. I can index it to get features and the label for each example. So here's what that looks like. I've got the image features and the image label. But there's a little bit of a problem, and you'll see that if I print the shape of the features. So for the 0th example, it's 127 by 284. For the first example, it's something different. And the problem with that is that most PyTorch models expect images of the same size, of a consistent size. So what I'm going to need to do is apply another transform to resize all the images. And again, I can get this from Torch Vision transforms. Think about it now, actually, the resize function is going to squish the image into that size. And what that means is they might not look like realistic images. So instead, I could do something like a random crop. Now, the risk with this is that I could actually crop out the key features of the image. But for now, I'll leave you to solve that on your own. So I'm going to go for a random crop. The first parameter it takes is size. So let's say I'll just go for, 256 by, actually let's say I go 256 by 256. Pretty decent sized image. And then I'm just going to need to resize that image once I've got it. I get an error, which is that this crop size is larger than the input image size, so I'm going to need to figure out what the minimum image size is. I could run through all the examples in my dataset, print their size, and find the minimum, but for now I'll just set it as something small. Great, so now all the examples in my dataset should be the same size, and I'm ready to go. But having printed all of those examples, it looks like there's another issue, which is that one of them is a grayscale image. It's only got one color channel. So to quickly debug that, I'll just print the file path, find out which image that is. Looks like this one, Hotdog with mustard. And so for now, just as part of the data cleaning, I'm going to remove that from my dataset. Now my dataset's looking pretty good, and I think I'm ready to go. Oh dear, one thing I forgot was to define how to get the length of the dataset. So in this case, it's pretty easy. It's going to be the number of examples and self.examples. So remember, this function defines a behavior for when I call Python's built-in len function on an instance of that class. And so in my case, what that needs to return is the len of self.examples. So the length of my dataset is 10 examples long. Very small dataset. Tiny. Nice, but that's everything working as it should do. So let's just take a look over and see how I can improve this code. Well, one thing is that this big chunk of code all relates to one thing, so that should probably be within its own method. I'm going to put that in a method called load examples. That method probably shouldn't be called from outside of the class definition, so I'm going to make it a protected method. So instead of defining the attribute in here now, I'd probably like to remove that and instead return the examples. And then I'll call that function inside the initializer to set these examples as an attribute. And I also need this stuff inside that function too. I might want to return these things or set them as attributes or something like that so I can use them later, but for now, that looks a lot tidier. The initializer has got everything that needs to set up the class, and it's very simple. This method abstracts away a lot of the details of that code, and then the other methods are pretty simple and easy to read. So that's the Hotdog dataset. So let's run that and check out what it gives us. Now something looks strange here because I'm only getting Hotdog images, so it's probably an issue which I need to fix. So why would I only be getting Hotdog images? Well, it's probably got to be in the load examples section, right? And okay, so I initialize the examples as an empty list. I get the file path for all the images in this folder. I add on the folder name to that, so it's the full relative path of the image. And then, so I overwrite my empty list of examples here. So I overwrite that with the list of the tuples of the images and the classes. So after the first run of this, examples is going to be equal to this for the first class, which would be dog. And then the next time it goes into this list, it overwrites that whole thing again. So eventually the examples which is returned is actually only the one from the most recent class. So that's happened because I've moved all of this stuff into this function and replaced this and this, which were previously self.examples, with examples, which is what this was in the first place. So let me change the variable name of this. So I'll say example tuples, like that. And then I'll extend this by example tuples. Now if I run it, yeah, great. Now it's got the dog images in as well. So that is looking good.